Our last section in chapter 6 is all about natural logarithms. So let's recap for a second. Remember that number e that we learned about? We figured out that e is approximately 2.718. It's called our natural base. Okay. So we learned about that number e, but we also learned how these exponential functions and logarithmic functions are related. So again, let's think of this function y equals 10 to the x. If I was trying to find the inverse of y equals 10 to the x, we switch the x and the y around. And then to get y by itself, remember this is where we have to use a logarithm. This is the log base 10 of x equals y. Okay, log base 10, that was a common base that we had along the way. Well, what if we had this, y equals e to the x power? If I was trying to find the inverse here, again, we switch our x and our y value around. X equals e to the y. And then again, to get y by itself, I have to use a logarithm. The log base e of x equals y. Now, just like the log base 10 is a common logarithm, the log base e is fairly common as well. It's so common, this log base e, that we have a special way of representing the log base e, and that's with what we call the natural log. Y equals the ln of x. So ln means natural log. And just like if we saw a log of x, we would assume, hey, that base is 10. If you ever see the natural log, this ln of x, then that tells us that the base is e. Now here's the good thing. Everything that we have done with regular logarithms, okay, log base 10, log base 2, any of those other bases, we can do the same thing with natural logs. So our log properties work the same way, and that's what we see in example 1. Write as a single logarithm. And I'll do 2 pieces here. The first piece, the natural log of 7 plus 2 times the natural log of 5. You might notice, hey, we have one log added to another. I have to multiply pieces, but again, we have to deal with this 2 first. This 2 goes in as an exponent. We have to do that first. So this becomes the natural log of 5 squared, or 25. And then from here, we can multiply the 2 pieces here, 7 times 25, to get the natural log of 175. Okay? And that would be written as a single logarithm. One more example quick. If I had 3 times the natural log of x plus 2 times the natural log of 2x, again, I have 2 logs added together, but first we have to get rid of these coefficients, really our exponents here. What we have to be careful with, right here I get the natural log of x cubed, but on this side 2x all gets squared. That gives me the natural log of 4x squared. Okay, because again the 2 and the x both go to this power. From here, multiply these 2 pieces, because again our log properties say if we have 2 logs added together, we multiply the pieces. We get the natural log of 4x squared times x cubed is x to the 5th. And that is my final answer.